It's one small step for man, one giant leap for mankind.
Planes are weird. But they fly. How do they fly? We don't know. Well, we kind of do, so I'm going to explain it. When a plane flies, there are four major forces acting on it. There is drag, there is thrust, there's lift, and then there's weight. There are a few major differences between them. So, we got first lift. Lift, when it goes this way, it's going to go up. It's perpendicular to where your object is going. It's a 90-degree angle. If it's going this way, the lift is going to go that way. If it's going this way, lift, it's forcing up. It's at a 90-degree angle most of the time, unless your plane is weird. After that, you got drag. Drag, it's on the opposite side. If your object is going this way, it's counteracting on that side. It's the opposite force of your object going through the air. If there's no air, there's no drag. We have to calculate it with the drag formula. The coefficient of drag, I'll go into that later. After that, we have thrust. Thrust is going up or sideways. So, it's created by using jets, propellers, rockets, anything you want. But we need a force moving forward. We don't have lift from it standing still. For an aircraft to actually, start flying, it needs to gain speed through thrust, start gaining lift, it's counteracting drag. Thrust counteracts drag and the effects of gravity. Gravity. Gravity is the force acting on our plane or whatever object while it's flying. It's acting on all of this. If there wasn't gravity, you'd be floating up in space right now. So, how do we counteract it? Lift and thrust. Well, first thrust, because we need to actually go somewhere, and lift is created from thrust. You might be asking yourself, okay, this is all fine, this is perfect. How do I calculate this? How do I find out what to do for this assignment? Because I'm stupid. So am I. But I made a whole calculator. It's going to be in the description. It's in the Discord server. It's everywhere. You can plug in your numbers there and it'll spit out everything for you. You need density or coefficient of lift, or it's going to calculate that for you. You will be using ARRI for this. If you don't, you can just look at all the formulas. I'm going to show up a couple images now and at the end of the video. But let's start with lift. There is a formula for lift. Lift is equal to the coefficient of lift times area, your affected area. That's either the wing, or you're going to take your combined area of whatever is going to be flying. So your stabilizer, your wing, all combine that together into one value, times velocity squared times density divided by 2. That is the whole formula. It's a lot simpler than it sounds. We gotta put up some images right now. It's very simple. For coefficient of lift, it is all those values combined into one number, and it's going to be in the formula. You can't really calculate it by our hand. We don't have the equipment, but it's in ARRI, but it's going to lie a little bit to you. I'll get into that later. For drag, believe it or not, same exact formula. Drag is equal to the coefficient of drag times affected area, velocity squared times density divided by 2. Same for coefficient of drag. Coefficient of drag is equal to drag divided by affected area times density, velocity squared divided by 2. Super simple. It is that simple that you don't have to do any math. You just have to plug into the formula and you'll get your drag at coefficient of drag. You can't have one without the other unless you're going to start guessing. For rockets, we can guess based off the nose cone. For our planes and gliders, we have to go off ARRI or whatever software you're using that's going to estimate this. We don't have a manual way of finding this ourselves so far. By the way, the kilograms in meters cubed and meters squared is the format we will be using for these formulas. You can use imperial system. There is a formula for it. You can Google it. I'm not going to show it. It's much simpler with the metric system. This will be a little different for weight. It's simpler to convert it to grams because it's easier to visualize. Oh, and weight. Weight is calculated by turning kilograms into newtons. So, you would technically should turn it into grams. I turned it into grams because it's easier to visualize. A gram is a gram. You don't have to visualize a kilogram pulling down your glider because your glider doesn't weigh a kilogram. how you would calculate this. It is 1 Newton times 0.0098. That is the force 1 gram exerts down in Earth's gravity. It's super simple. There's nothing else you need to do. Can you calculate it in kilograms? Yes. It is 1 kilogram is 9.8 newtons down. That's all you have to do. For thrust, we're not going to be calculating it this time. However, if you were, it highly depends on your engines, your efficiency. It's a whole nother thing I'll get into later if you like to. Other than that, that's pretty much it. Oh, and all the sources are going to be in the bottom with all the images and the drive and Discord, and have fun joining that.